Mind, we have to go to the part of halogenalkanes. In the halogenalkanes, we understood what? In the halogenalkanes, we understood that if we consider a alkane, right, if you consider alkane, if you consider alkane, if you consider alkane, if you consider a halogenalkane, right? Fine. What's the difference? In alkanes, the what will the electronegative pair differences, mind? 2.4 minus 2.2, that is
0 point.
0.2, that is approximately 0, isn't it? Clear?
Yeah.
Understood? Clear? And when you replace a hydrogen with a chlorine, what happens? Tell me. It gives a very bigger impact. Alkane is non-polar, right? Isn't it? Why? Because internationally, almost this point 2 is taken as 0. It's non-polar. Thus,
Yeah.
alkanes is non-reactive, isn't it? Clear? Fine. Is it
Yeah.
clear to you, right? So now over here, we have to understand that whenever we are seeing this, right, we can understand that when you replace a hydrogen with chlorine, right, when you replace a hydrogen with chlorine, right, isn't it? Right? Whenever we replace a hydrogen with chlorine, that gives a enormous amount of changes. What the changes do we do? Gives an enormous amount of changes, right? Isn't it?
Electronegativity
That
difference.
electronegativity gets ruthless, right?
Yeah.
This halogen is an electronegative element, right? So it pulls the electron cloud away from chlorine. Is it clear? Making it
Yeah.
delta negative and making it delta positive, right? Clear? And tell me one thing, that who will be getting attracted to the delta plus area? Who will be getting attracted? Electrophiles or nucleophiles? Tell me.
Electrophiles.
Electrophiles. So electrophiles will be getting attracted towards this. Is it clear? Got it? Understood. And what happens? Electrophilic substitution reaction occurs. This CCl bond breaks heterolytically. Is it clear? Just remember one thing. Only free radical substitution of alkane will be undergoing by homolytic bond breakage, isn't it? Bond breakage. Understood? Clear? Homolytic bond breakage. Clear? Other than this, all reactions will be undergoing by heterolytic bond breakage. Is it clear? Understood? Clear? Did you get this thing?
Mm.
Right? All the reaction will be undergoing by heterolytic bond breakage. Is it clear? Mind, did you get this thing? Fine.
Yeah.
So it's a very important part we have to understand, right? Isn't it? Fine. Did you get this thing? So now going to this thing, next part is that if you see that when we see a particular reaction, this is called as a nucleophilic substitution reaction, right? Why a nucleophilic substitution reaction? Because a nucleophile, right, a nucleophile will be attacking over here, and this will be taking out this. Is it clear? So a substitution reaction occurs. What kind of substitution reaction? Nucleophilic substitution reaction occurs. Clear?
Yeah.
Understood this thing? And why
Yeah.
this reaction is important? Can you tell me why this reaction is important? Can you guess why this reaction is important? Tell me. Because this generates what? Alcohols. Understood? This generates alcohols, right? Why
Yeah.
alcohols are important? Mine. Alcohols are important because it is the most important industrial solvents. Understood? Clear? Industrial solvents. Understood this thing clearly? Is it clear to you? It's the most important industrial solvent. Got it? Understood
Yeah.
this thing? So it's a very important part we have to know, right? Now go to the next part, right? We have to understand that whenever we are seeing this reaction, right, this will be a nucleophilic substitution reaction. And what happens? The OH minus will be attacking this delta plus, and this bond will be breaking heterolytically. Is it clear? Fine. Is it clear to you? Right? Heterolytically. Is it clear? Got it? Understood this thing? This bond will break heterolytically. Is it clear to you? Did you
Yeah.
get this thing right? Now going to the next part, right? If you see that whenever we are seeing this reaction, right? Whenever we are seeing this reaction, right? The mechanism by which it goes, right, is fully dependent upon whether this carbon is a primary carbon or a secondary carbon or a tertiary carbon. Mine, is it clear? Understood?
Yeah.
The mechanism by which it goes depends on what, Mahin? Depends on whether this carbon is primary carbon, secondary carbon, or tertiary carbon. Is it clear, Mahin? Any questions, please tell me. Is it clear to you? Any questions, please tell me. Is it clear? Any questions,
This
please
is
please come back. Got it?
good. Yeah.
Understood this thing? Fine. So this is a very important part we know that it will be undergoing which mechanism? Where this carbon is either primary, secondary, or tertiary, right? Now
Yeah.
we have to quickly discuss about what is primary, secondary, and tertiary. Going to the back side, right? What is the primary carbon? Can you guide me?
connected to more than two H2. Like,
So we have to
connect
see
to
that
only one group.
what is the primary carbon, what is the secondary carbon, and what is the tertiary carbon. We have to go into this important detail. It's very easy. You know it already, right? A primary carbon is a carbon which is connected to the functional group or substituent,
Yeah.
and it is connected to at least two
Yeah.
hydrogen. At least you have to use this vocabulary. A secondary carbon atom is a carbon atom which is connected to only one, isn't it? Only one. Understood? Only one. Correct? Only one hydrogen. Is it clear? Fine.
Mm.
What is a tertiary? A tertiary carbon atom is a carbon atom which is connected to no carbon. Isn't it? No carbon. Isn't it? Sorry, no hydrogen. Is it clear? Did you get this thing? No hydrogen. Is it clear? Did you get this thing right? Fine. So this is a very
Yeah.
important part we have to know, that whenever we are seeing this, right, we can understand that it will be having what? It will be having a primary, secondary, or tertiary. We can get to know, right? A
Yeah.
tertiary carbon has got no hydrogens, right? See, no hydrogens attached, right? There are many ways by which you can, by many people do the methyl group, right? Don't do the methyl group. Is it clear? Fine. Now come to the
Yeah.
next part, right? If you see that when we utter the word, that nucleophilic substitution, right? Nucleophilic substitution will be undergoing if the carbon is primary, secondary, or tertiary. Now write down this. In a primary carbon or in a secondary carbon, what happens? The OH group will be attacking from the backside of the molecule. Is it clear? Fine. Why? You might be understanding why. Now write down this important part. The alkyl group, if you see the alkyl group, right? The alkyl group, always remember, the alkyl group will be always and always having two important features, right? It is a very bulky group, isn't it? Fine. Very bulky group, isn't it? Isn't it? Very bulky group. Any
Yeah.
alkyl group, methyl, ethyl, propyl. Second, alkyl group has got an electron pushing effect away from itself. Is it clear? So if you have got an alkyl group, what happens? It will be pushing electrons away from itself. Is it clear? Is it clear to you? Understood? Pushing
Yeah.
electrons. This is called as what effect? Can you guide me? This is called a what effect? Inductive effect. Is it clear?
Inductive. Okay.
Inductive effect. This is also called as plus I effect. Is it clear, Mahin? Got it? Understood?
What?
Plus
Okay.
I inductive effect. Now write down this. If anyone pushes electron away from itself, this is called a plus I inductive effect. If anyone will be drawing the electron towards itself, right? This is called as the minus I inductive effect. Clear? You have
Yeah.
to know these important points, mind. These important points, right? We do. We have to do what? We have to take that either or not this carbon is primary, secondary, or tertiary. We have to keep this in mind that if the alkyl group is there, alkyl group is very bulky group, right? And there will be a plus I inductive effect, right, of the alkyl group. Very bulky. It's open space. But in primary carbon, what happens? You have got very small hydrogen, right? Like ant. A alkyl group is like an elephant or a tiger in front of hydrogen, which is like an ant. So OH group gets a space, isn't it? Vacant space. Can you see this? Vacant space to attack this delta plus, isn't it? And we get a unstable transition state. Is it clear? In SN1, you'll be seeing that you'll be getting a carbocation over here. Is it clear to you? We're getting a carbocation over here, right? But in SN2, this is a SN2 reaction where we're getting a transition state. In the transition state, this bond is breaking and this is bond is forming at the same time, right? And next step is a fast step. What happens? The Cl minus will be leaving. Is it clear? Understood? Now this reaction, what we have to do, this reaction, what is the rate law of this? We know that rate law will be the rate expression of the slowest step. Is it clear? Understood? We
Yeah.
learned in the kinetics chapter, rate expression will be the rate expression will be the of the slowest step. Mind, is it clear? Fine. Now, can you write down the rate expression of this quickly? What's the rate expression of this reaction? Rate will be equal to Rx, halogen-alkane, to the power of 1, because 1 stoichiometry, into the nucleophile to the power of 1. Is it clear? Got it? So
Yeah.
this is a bimolecular, right? Two molecules are involved in the slowest step. That's the reason it is bimolecular. Or SN2. 2 signifies bimolecular. Is it clear? Understood this
No.
part? Fine.
Mm.
But you guys think. Now coming to this part, that if you see that this reaction will be taking place in aprotic solvent, right? What are aprotic solvents? Can you guess? Aprotic
They
solvents are those
on
which do not form hydrogen
hydrogen.
bonding.
Yeah.
Means they don't have phon, which I taught you earlier. That hydrogen
Yeah.
bonding will be there for those species which will be having fluorine, oxygen, or nitrogen. Is it clear? Right? Is it clear to you? Oxygen or nitrogen. Is it clear? Got it?
Yeah.
They will be having no oxygen. They'll be having oxygen, fluorine, nitrogen when they're forming the hydrogen bonding. So why does aprotic solvent need? Can you guess? Because if you're taking a protic solvent forms a hydrogen bonding. It will be solvating this and it will be stopping it from attacking it. Is it clear? This OH minus should be like a bullet, free bullet, not hindered. So if we take a protic solvent, that protic solvent will be forming hydrogen bonding such as water. Water is a protic solvent. This will be hydrogen. This will be actually This will be solvating, and thus it cannot attack. Clear? And thus we are seeing what? Thus we are seeing that it will be undergoing a aprotic solvent. Clear? Now next
Yeah.
reaction. We are going to the part of the tertiary carbon. Why this is a tertiary carbon? Can you guess? Why this is a tertiary carbon? Can you guess?
No hydrogens are connected and it's connected to the functional groups here.
There's no hydrogen group, right? Now, if you have got a tertiary carbon, right? If you have got a tertiary carbon, remember, a tertiary carbon will be undergoing via a SN1 mechanism. Why? Now, in the last example of SN2, we saw what? There were two hydrogens attached to it, right? Over here. So there was space of attacking. Now, what did I tell you? Alkyl group will be constituting a bulk, mine, isn't it? So this will be a
Yeah.
bulky group, right? Bulk. Is it clear to you? This will be a bulky group. And they will be stopping any OH minus from attacking. Is it clear? From the back
Yeah.
side. So first step is what? First step is that this Cl minus will be leaving out. And we're getting a carbocation over here. In SN2, what we get? We get a transition state. Practice this, I'm telling you. Practice this, hand practice this, transition state. But here we're getting a carbocation. Is it clear? Carbocation. Is it clear? Fine. This carbocation does what? This carbocation will be what? Will be stabilized. This has to be stabilized, isn't it? If the positive charge, carbocation is very unstable. If it is not stabilized, what happens? The Cl minus will be again recombining back. So if somehow if the positive charge is lowered, right? Somehow the positive charge is lowered. That helps, isn't it? That helps. So the
Yeah.
positive charge is lowered by what? The positive charge will be lowered by electron pushing. Is it clear? Because alkyl group, I told you what, has got a positive inductive effect. Is it clear? It will be lowering the carbocation, right? Charge, stabilizing it. Next step is what? The OH minus will be attacking from the same side. Here it's a very important same side as the Cl minus left. In SN2, the OH minus attacked from the opposite direction. Can you see this over here? It attacked from the opposite direction. Can you see this? Because there was
Yeah.
space. Opposite direction as the Cl minus left. Now, you just remember this thing. If you take, if you see the if you see that particular the profile diagram, mind, can you open 10 HL? Quickly open 10 HL. Now, we just sent to you. Now, over here, we just see that the the energy profile diagram of SN2 is what? SN2 will be a single hump. Is it clear? And SN1 will be what? A double hump. Is it clear? Double hump like this. Is it clear? Got it from over here? Now, second thing is that if you see, when we see a SN1 reaction, the slowest step is this. Now, can you write down the rate expression? Rate expression will be the rate law of the slowest step to the power of stoichiometry. We learned, right, in kinetics. Can you write down what is the rate expression of this? Mine? Quickly write.
This will be the RX.
A rate will be equal to K Rx to the power of 1. Is it clear? Fine. Is it clear? Fine.
Yeah.
Is it clear? Rx to the power of 1. Is it clear? Got it?
Yeah.
Did you get this thing? So it's a very important part we noted, right? Clear?
Yeah,
Now
sir.
this is a unimolecular reaction. So SN1. Understood? Clear? Now, how
Yes, sir.
does the energy profile look like? This is a complete two steps. Can you see this? Complete two step by a carbocation. So you make the first hump higher, transition state, next hump smaller. Is it clear? Understood? The hump will be telling you the which step is slowest step. Understood? If
Yeah.
the transition state has got a higher energy than the second transition step, so the first step is the slowest step. Is it clear? Got it? You can understand
Okay.
which step is slower by the transition state hump. See, can you tell me that in this in this two-step reaction, which is the slowest step, first step or second step in this? Right? Yeah, tell me.
Second step.
Second step. Is it clear? I'm revising the kinetics also, which will be linked over here. Understood? Did you get this thing?
Yeah.
So this question will be linked to the kinetics order of the reaction, right? We'll find out the order of the reaction. This question, this type of question. Clear? Now
Yeah.
we have to go into a very important part. Now always remember that SN1 reactions will be fastest. Is it clear? Fine. Fastest.
Yeah.
Is it clear? Fastest. Clear? Isn't it? And SN2 will be the slowest. Is it clear? Understood?
Yeah.
Clear? Got it? Now, if you take a chlorine, a bromine, or a iodine, for we understood that the primary, secondary, tertiary will be influencing the speed, right?
Yeah.
Tertiary hydrocarbons will be the fastest. Clear? Now, can we also the leaving group influence? Yes. Now, if you have got CCl, CBr, CI, which will be the faster? Can you guide? Which is
Um.
faster? Now, remember one thing: in any reaction, bond breakage needs energy. Is it clear? Needs energy.
So
Bond
chlorine.
formation releases energy.
The chlorine
In
one.
this reaction, what happens? The bond breakage, if it is easier, then it will be faster. Is it clear? Got
Yeah.
it? Now, which bond is weakest? Weakest will be faster.
Chlorine.
Which bond is weakest? Chlorine,
Yeah.
bromine, or Ri? Which? Think and tell. Don't jump.
Iodine.
Iodine. Why? Brilliant answer. Because iodide, the nucleus is far away from the carbon. Sorry,
Yeah.
shared pair of electron. Right? Isn't it? In the
Yeah.
RCl, what happens? The nucleus is closer and held the nucleus closely. Isn't it? Ri. Got it? Will be
Okay.
weakest and thus it will be fastest. Is it clear? Got it? Got it?
Yeah.
Is it clear? So we can now summarize this word. Summarize this word. SN2 will be having a single hump, a transition state. SN1 will be having a double hump, and the first step will be having the slowest step, and it moves via the carbocation intermediate. It will be taking place. SN2 will be taking place in aprotic solvent. SN1 will be taking place in protic solvent. Right? I forgot to tell you that
Yeah.
SN1 takes in a protic solvent. Why? Because protic solvent will be forming a hydrogen bond. This carbocation is the main species to be taken care of, right? Taken care of, right? Here, this carbocation, unstable. If you take a protic solvent, the water molecules will be lowering the positive charge by its delta minus. Is it clear? Understood?
Yeah.
Clear? Somehow you can lower the positive charge. It will be making this carbocation more stable and not reacting with the Cl minus again to form the halide again back. So
Yeah.
this is lowered by what? By the electron pushing effect of the alkyl groups. Second, the delta minus of the oxygen, right? They will be doing what? They will be lowering down the positive charge away. Hence, we use what? Protic solvent. What are protic solvents? Protic solvents are those
Allow
which will
hydrogen.
be having hydrogen bonding, right?
Yeah.
Which will be having hydrogen bonding. Clear? Mahin,
Yeah.
understood this thing clearly? Fine.
Clear.
Mahin, now can you just share your screen, please? Thank you. Do the question number one. This is a two-part question. Can you see this?
Yeah.
Fine. You see that which statement of the can you underline the most important word over here? Can you understand what I'm saying? You don't have to do the questions and do with the pencil and pen and paper. No. Read the question, tell yourself the answer, go to see the answer key in the bottom, right? Right?
Yeah.
Now do it.
This should be.
Can you tell that which is the most important word over here? You're not underlining or circling.
I did halogenoalkane only and
Mm-hmm.
aqueous sodium hydroxide.
Yeah, yeah. This is the most important word. Understood? Correct. Hmm. Correct.
No.
Now do it.
So
Primary halogenoalkanes react by SN1 or SN2. Which? Tell me. Correct also. What are you doing?
the SN2.
SN2. Answer. Is that the answer? Chloroalkanes is faster than iodoalkanes. What we learned?
No, iodo.
Mm-hmm. Iodo.
And then
Tertiary
yeah,
halogenoalkanes are faster
fine.
than primary. Yes. Which reaction? SN1 reaction.
One.
Rate of the SN1 reaction depends upon the constitution of sodium hydroxide.
No.
Rate equal to? K Rx to the power of 1. Is it clear? Fine. Hmm.
Yeah, so not on this. So
Is it
now
clear?
let's see.
Clear?
Yeah. Then so we've not done optical
No
isomer.
optical isomers we have not done. Go to question number 3. Optical isomers is there.
I don't think so. So
Okay,
no.
fine. Up. So which one most rapidly in a SN1? So this is SN1, this is
Yeah,
SN1, this is
these two are
SN2, this is SN2, right? So this will be
plus
what?
these
This
two
will
are
be
out. Sorry,
fine.
sorry.
Hmm.
These
Hmm.
these
Now,
two are out.
yes, yes, yes. Now
This
go down, please. Go down.
which one though?
Wait. This is this question number 10. Okay, no, no,
Uh,
no, no, no. Yes, this don't do this. Just learn. Just learn. It can come in your exams. See, nitrile group is this, right? Send me a message, please. Page number 470 Pearson to revise functional groups. Huh? Functional group to revise.
okay.
For Pearson, page number 470, right? This will be there.
Couldn't
Understood?
it? Because it's if you
Because
count.
it will be right. Clear? So to
Yeah.
count the number of carbons, wait, 1 carbon, 2 carbon, 3 carbon. This is a brilliant question. See, brilliant question, right? See.
Yeah,
Now to go down, please. This is all hard work which I've done for the past 7-8 years. Can you do this? Can you do this? What's the
which
correct
one?
IPAC name for this compound?
So which compound it doesn't show?
Hmm.
So which
Tell me.
so
Oh, wait. This structure is not there. Can you go down, please? Go down, go down. Right? Go down, go down, go down. Wait. Enantiomers. Can you check enantiomers is there or not, right? And can you tell this? Wait. Uh, this one. Question number 18.
most readily by uh, isn't this? Is it C?
Hmm. Perfect. 1 minute. CS3Cl. Perfect. Next. Let us check. This is a very interesting question. This is iodine, huh? This name, but this is not Cl. Anyways, wonderful, right?
Yeah,
So we've yeah.
yeah.
What is this? Can you just tell that